Good evening, ladies and gentlemen. On behalf of our over 34,500 members, I want to welcome you all to Region 2. I also want to welcome you to the Washington, D.C. area, my home. I now have the pleasure and honor of introducing the 2002 IEEE Vice President of Regional Activities, a member of the Utah section, and a good friend, Cleon Anderson.
It is my opportunity to call this Section Congress to order. I welcome you, my fellow delegates, to the Section Congress, and want to tell you that we have 297 sections in IEEE, of which over 270 are represented here tonight. This is the largest gathering of IEEE leadership ever held. We have approximately 0.2% of the entire membership of the IEEE in attendance. The leadership of the major boards and committees of IEEE are also in attendance. As the IEEE section leaders, you have unparalleled access and opportunity at this Congress to educate our staff and the volunteers at the highest levels of the organization. As volunteers, you are the genius of IEEE. Today, we are truly networking the world and creating the global community. Section Congress is organized under the direction of the Regional Activities Board. We usually call that RAB. It is supported by all of the other major boards and committees of IEEE. By sponsoring this Section Congress, RAB is fulfilling that part of the IEEE vision of advancing global prosperity by promoting community worldwide. Our vision of IEEE is to advance global prosperity by fostering technological innovation, enhancing our members' careers, and promoting community worldwide. And by the way, that is a good definition that you can use for your friends and family when they ask you, what do you do in IEEE and what does IEEE do? By the way, this Congress has been held every 3 years since the centennial year in 1984. Together at this Congress, we expect to find the ideas and issues and recommendations that will shape our organization for years to come. Together, we will look at our strengths and our weaknesses, our opportunities and threats, and these ideas and recommendations will become part of our strategic plan. As Vice President of Regional Activities, I mailed to you the final report of the 1999 Section Congress that was held in Minneapolis, Minnesota. Several of the 1999 recommendations have been implemented with great results. Other recommendations have been a disappointment. But also on your chair this evening, you have a one-page update on some of the successes that we've achieved this year in IEEE. It is now your turn as volunteers to refocus the management of IEEE. And in this exercise, you're expected to educate and challenge both the volunteer leadership and our staff. I guarantee to you that what we do here will affect the vitality, the growth, and the relevance of IEEE throughout the world for at least 3 years. I now introduce you to the Chair of Section Congress 2002, Dan Benigni.
Good evening, everyone. I hope you enjoyed the montage and the picture wall outside. I wanted to thank all of those sections that sent in their pictures. I hope that those of you who didn't do it next time, because it's wonderful to see all of those pictures flashing by. And especially, I hope you heard the music. It's a favorite of mine and Maureen's. It's the Jupiter Symphony by Mozart. On behalf of my committees, the 3 sponsoring sections, and regional activities staff, welcome to Sections Congress 2002. We have been working and planning and meeting for the last 3 years to bring you the best experience we can while you are here. As Cleon said, we have the largest attendance of any Sections Congress in history. Thank you all for coming. We have lots of folks in attendance. As Cleon said, a lot of the high-level volunteers are here. Rather than introduce one by one and get everybody confused and miss a few, let me just ask people to get uncomfortable and stand whenever I say who they are. Let's start with presidents, past, present, and to come. If you're here, stand up and be recognized. Members of the Executive Committee or the IEEE Board of Directors, you know. It is your input we are seeking. It is your issues and ideas we need to capture this weekend. Our RAB leader, Cleon Anderson, has struck the gavel, or I think it was his fist, officially calling this Sections Congress to order. So let's get started. It's now my pleasure to introduce to you our local organizing committee chair for Sections Congress 2002, Satish Aggarwal. Satish is the former chair of both the Washington section and the National Capital Area Council, and he is a longtime member of the IEEE Standards Board. Satish and his committee have worked long and hard to make sure that all the myriad details of our local arrangements have been made to ensure you a great stay in our city and a great Congress this weekend. Satish?
Thank you, Dan. Ladies and gentlemen, good evening. It gives me great pleasure to welcome you to our nation's capital. Washington has a wealth of culture, history, and scenery for you to enjoy. You and your partner will have ample opportunities to enjoy all that our capital has to offer to you. We want and hope that the event at this Section Congress and Washington, D.C. will be truly unforgettable. On a personal note, during the next 3 days, I plan to meet with each of you in person. I would like to hear from you your experiences and views about the events in Washington, D.C. On this occasion, President Bush intended to greet you via video link. Because of the budget constraint, we were not able to establish a video link. However, I have a presidential message. The White House, Washington, October 17, 2002. I send greetings to those gathered for the Institute of Electrical and Electronics Engineers, IEEE Section Congress 2002. Engineers play a vital role in maintaining America's strength and prosperity. By developing innovative scientific and technical systems, processes, and design, you fuel economic growth and contribute to countless advancements in aerospace, computers, telecommunication, biomedicine, electric power, and consumer electronics. These meetings provide a unique opportunity for our world's leading electrical and electronics engineers to share ideas and solutions to the technological challenges of the future. I commend the IEEE and those involved for your dedication to enhancing global prosperity through innovation. Your important efforts are helping to improve the quality of all life all around. Laura joins me in sending you our best wishes. Let me now turn to our sponsors. As you know, the three capital area IEEE sections are in Region 2, who are the main sponsor. In Region 2, we have about 20 IEEE sections, and united we stand in sponsoring the Section Congress 2002. It gives me great pleasure to recognize those sections one by one. And as I name, please delegate a representative of that section, please rise. Akron. Probably people are late. Baltimore. Central PA. Cincinnati. Cleveland. Columbus. Dayton. Delaware.
Is the largest international engineering project ever undertaken in space, and it is the first truly global space exploration effort. It represents a most appropriate tie-in to our Congress's theme of creating a global community. Down here on Earth in June of 1999, Mr. Michael Haas was named to his current position of Deputy Associate Administrator for Space Development at NASA. His primary duties include directing the space station budget, establishing and implementing station policy, coordinating external communications, and serving as liaison to the administration, U.S. Congress, industry, and NASA's 16 international partners, among other things, and other people, and other groups. Prior to his current assignment, Mr. Haas has served as the Deputy Director of International Space Station Requirements, as Chief Engineer of the International Space Station, and as the Manager of Utilization and Operations at the Space Station Freedom Program Office. Mr. Haas has been with NASA since 1978. Here to tell you more about the International Space Station effort and the global partnership that he has helped to create and maintain is Mr. Michael Haas. Let's all welcome him.
Well, thank you very much. If I can figure out how to get the computer open up here. Dan explained to me a few minutes ago that I had the pleasure of being the largest block of time in between several hundred people and dinner. Therein lies a very unique challenge, so I hope that I can be interesting and informing. When I first, I'm not going to use it yet, I need to get it up after. When I first responded to the inquiries about being able to speak at the Congress, I was getting all these email messages from Tracy Hawkins. And I said, okay, space station, IEEE, I understand that. And then she mailed me a brochure finally, and I read Creating a Global Community. Duh. I think I get this now. I understand why this ties in a much bigger way than just the interest of a big community of engineers. And I think that's a terrific tie-in, that space station is an enormous global endeavor. And keeping the activities of all 16 partner countries laced together is quite a challenge. Not only does it entail the nuts and the bolts and the bits and the bytes of the engineering challenge, but much larger, it entails unique politics and culture, individual domestic needs, and rights and privileges across all of these partner countries. And what I'd like to do is take you through some of that, not so much the nuts and the bolts and the bits and the bytes, but how we actually make this work. But what I'd like to do to start out with is actually let our partners tell you. And I have a short video that is actually made with all of our partners, the engineers and trainers and the managers, all describing what this huge endeavor means to them. So if we could go ahead and roll the video.
Wonderful picture of a ship, and the sign underneath the ship is the only time a ship is safe is when it's in the harbor. But a ship isn't built to stay in the harbor, so it loses its purpose if it can't do what it's supposed to do. NASA loses its purpose if it cannot take a trip. That's all.
Space program said that the Earth is the cradle of mankind, that you can't spend all your life in the cradle.
We go to space in order to explore. We are explorers by nature. That is the way humans are.
We learn things from our exploration, and we bring things back from our exploration.
I think we're getting a better understanding of our solar system. So with that better understanding comes a wish to be there, to go and look for yourself. And the International Space Station is the next giant step.
With the International Space Station, we will have a permanent presence of mankind in space, and I think it's a tremendous step forward in the exploration that we are doing of our universe.
International Space Station is an orbiting laboratory flying 220 miles above the Earth. Imagine the complexity of the task. Space Station is built piece by piece on the ground by 16 different countries around the world and then assembled in space. Starting in 2001, Space Station is a fully functioning research outpost made up of living quarters for the full-time crew.
You can tell that it was my budget that had to fund this film. I got my little 2 seconds of fame in amongst all those very eloquent people. I understand that you have an opportunity tomorrow night at the Air and Space Museum to see the 3D IMAX movie of Space Station. I heartily recommend that to you. You've seen a nice movie here. Tomorrow you will be the closest most of us will ever have an opportunity to be, to really experience and understand what the space station is all about. So in between a nice movie tonight and a really great movie tomorrow, I'm going to drop back and be a typical engineer and bore you with some PowerPoint slides. So if we can go ahead and change to the feed for the computer. know better than to trust me. I was told I really shouldn't admit to several hundred IEEE members that I'm actually a Macintosh user, so. The fact that they're even trusting me with a PC up here in front of me is some great measure. Space Station has a very long history, and it's a project that has been mired in controversy. I reminded some folks early on this evening that back in the late 80s when I started on this project, IEEE and many of the technical associations were not at all in favor of this project for a variety of reasons, many different reasons. But in spite of that, and in spite of all the differing politics, it has survived, and it has continued to actually thrive over the last few years. So the first question I pose is, how has this global team done? And in looking at the progress of human spaceflight, they have done phenomenally. They have outperformed any endeavor in human spaceflight in terms of the number of flights, the different partners, the equipment coming together that has never seen its partner before it gets 200 miles above the Earth. So as of this morning, we've accomplished 15 shuttle missions, 8 Russian Progress launches, 4 Russian Soyuz launches, 2 Russian Proton launches of major elements, and 1 additional Soyuz launch with one of the smaller Russian segment components. Since November, when we launched our first crew, we have continued to rotate humans on board the space station. We have completed 4 expeditions. The 5th expedition actually gets to go home in November on the next space shuttle flight. And we have maintained this continuous human presence for nearly 2 years. This is the space station as it looked last week, which, similar to the picture that you saw in the movie, the large solar array, the U.S. laboratory module, is towards the front of the picture. The small robotic arm is a Canadian arm. And this is a picture of the newest component of the space station, which is one of the outside truss pieces, which was delivered this past week by the Atlantis crew. Delivered and connected, and again is working extremely well. One of the very unique challenges of space station is that you have to build all of these components on the ground. You have to test them. They never all see each other together. And oh, by the way, every trip that you make needs to be its own functioning spacecraft. So every one of these 40-plus stages of assembly all have to work as a fully functioning spacecraft. These are the partner countries. And I think you heard a lot in the movie that these countries feel very strongly about this program, but they feel strongly about it for a variety of reasons. The United States, Russia, coming from actually very similar experiences and heritage in human spaceflight. Canada, Japan, and Europe have partnered particularly with the United States in many projects in space. Europeans particularly have also partnered with Russia on several activities. You can see the unique challenge in Europe in that not only do you have to manage yourself as a space agency, but you have to manage all of those individual government ministries all together in one time. The way Space Station is organized is we actually have some of the activities have to take place at the government level. There's 15 votes. Some of them happen at the space agency level. There's 5 votes. Obviously, we fight and work really hard to keep it 5 rather than 15, just to actually make progress. One of the things that makes the challenge of flying Space Station so difficult, and was mentioned by some of the folks, is that even though it was built in Russia, or it was built in Alabama, or out in California, or in Canada, or in Japan, or in Bremen, or in Torino, once it gets there, it's all one integrated piece, and it has to be managed and run as an integrated, functioning laboratory. All of the comments that you heard about what are the science phenomena that are so different and so exciting that we have only begun to tap in the shuttle experience we've had. it has to be coordinated all together as one facility. There's only a finite set of resources. There's only so many crew members. There's only so much power. There's only so much data capability, and that all has to be shared. So we have very involved calculations about who gets what literally because of what they have provided. We have learned over time that there is nothing that one of us does that doesn't affect the other 15. We have found that in very pointed ways. One of the kind of a humorous anecdote is our Russian colleagues for years have been much more aggressive about commercial activities in space. And so some folks may remember when one of the major Russian components was launched, there was a Pizza Hut logo on the side of the booster that carried it into space. And the Russians, this was not unusual. They had done these activities before. Well, all of a sudden, we got a call from Mission Control Moscow to Mission Control Houston saying, can we use the convection oven in the laboratory module? So, well, we haven't even powered that up to test it yet. Why do we need a convection oven? Well, the crew thinks they'd like to heat the pizza. The pizza? By the time they got through the procedures for the oven, I think the pizza was long gone. But it clearly demonstrated that there's really nothing, no member country is an island in this project. The research activities themselves are a huge number of fields and disciplines. Life science activities, metallurgical sciences, combustion sciences, a lot of the different activities that you heard in the video. Assembly, as I said, is over many years, and each stage has to be fully functioning and safe over those times. And now we are also in a process where you are going to resupply. This is not just a satellite that you're going to launch and maintain from the ground and pray and work your computer programmers to death to keep it going. You're going to work a lot more people to death because you're now going to bring supplies every few months, and you have to plan for when is that train going to go to the space station. And it may not be a shuttle, it may be a Russian Progress, it may be, a few extra kilos on a Russian Soyuz that is exactly what's needed for this point in time. This is the space station as it is planned, and it's color-coded to show you who provides what. And as you can see, across the center, in green, which that should look like green to you, is what the US provides. In red are the elements that the Russian Space Agency is planning to provide. There are a couple items in blue, particularly in the front, that are actually US elements, but because of obligations, cost obligations, we actually have different partners building for us. Japan is building an additional research laboratory. The European Space Agency is building additional connecting nodes, and that's how they are actually offsetting debts that they have to the United States. The Canadian elements are in the center in yellow, and the Japanese laboratory elements are on your right-hand side at the very front, which should be kind of an orange color, I think. And then in purple is the European laboratory, and in this projection, purple looks almost like blue, so it's on the right-hand side, or the left-hand side for you of this chart. You can see, obviously, that the United States is the managing partner. We provide most of the infrastructure, most of the capability, the data assets, communications, the primary electrical power, thermal cooling, all of that is provided by the U.S. And because of that, in our sharing arrangements, the U.S. actually gets the predominant share of those critical resources to use for our own research program. In terms of the management structure, and again, getting back to this global community, how do we really make this work? The challenges that we have is that by the agreements we have set, all partners have a role in the management. They all have a vote. Whether it is at the agency level, where it's 5 trying to agree, or at the individual government level, where it's 15 trying to agree, they all have a role. They all have the rights to those resources for their own research programs. They also have an obligation to share in the ongoing operations costs of this whole facility. They all have an opportunity to provide their crew. This is a very important right in the countries who do not have as much experience in human spaceflight and have not had those opportunities. And they also have additional right to purchase from the US or Russia additional transportation services. They can also sponsor another nation. The U.S. so far has been the only one that has done that, in that we have done a side arrangement with Brazil in terms of trying to provide some of the U.S. components. The provisions are all in the agreements to allow other nations to join this enterprise. We're not actively pursuing that, but it's all there, and it has been affected once and certainly can be affected again. In terms of the management complexity, this is where I'm pouring my heart out, the challenges we have. Every decision is complicated because it's many decisions. There is basically no one thing that you can really go and do. Everybody has budget processes. Over time we have all gone from countries that are economically strong to countries that are having economic challenges and issues. Probably every partner has had some version of an economic challenge in their program that they have had to deal with. We continuously operate the facility, so we run over every time zone. We have people functioning in Moscow and in Houston and in Canada. Outside of Montreal, we have a control center that helps monitor the Canadian robotic elements. We'll have control centers in Europe and in Japan as well, as their elements come online, that they will be supporting those elements. We are not all in this for the same reason. As I said, there are differing domestic goals. The U.S. has a long tradition of human spaceflight, as does Russia. So for many members of our stakeholders, the human presence in space, the exploration mission, those are all meaningful drivers for why a space station. But in the other countries, they don't anticipate having those kind of programs, and the real yield from the research is a much stronger driver for there. So we have to recognize that we have all these differing agendas. And each one of our countries has to demonstrate value to their own stakeholders based on these differing agendas. Communications has been a challenge. We have, in most of our relationships, have found that English does fine as the language of the program, but in many cases we find that you just cannot survive that way. Our Russian colleagues, English was not taught as a foreign language very often in the Soviet Union. If it was and you're very good at it, you probably had a different job before you started at the Russian Space Agency. We have had to deal with interpreters, and we have had to deal with how do you interpret highly complex and technical activities through interpretation and all the vagaries that can be introduced in that, and that's been quite a challenge. Where we typically at NASA have had one or two people deployed across the globe to help monitor all these kinds of projects, we have literally hundreds around the globe now, most of those in Moscow, because of the challenge of bringing the Russians into the program, particularly in bringing them in several years after the rest of the partnership had been up and functioning. Technically, safety is always number one. But understanding what safety means to us and what it means to the Russians and the Japanese and Canadians and Europeans are all unique challenges. People often portray our Russian colleagues as being more cavalier or more risk-taking than the U.S., but on many functions they will dig their heels in mercilessly, where they are absolutely confident that this is the only safe way to proceed, and we have to work our way through those challenges. Understanding how we do specifications, standards, what are the engineering assumptions in your analysis, verifying that all these interfaces are in fact in some way controlled and tested and verified. Software, I'm not even sure that I need to say much. This has more software than any spacecraft ever devised, well over 2 million lines of code that has stressed every one of the systems of the developing nations. How do you get early warning of problems when all of your development sites are spread all over the world? And then planning for the resupply is something that NASA has not had to do. The shuttle comes home. It comes home and it gets hundreds of technicians that crawl all over it and fix it and repair everything. This isn't coming home. So you have got to figure out how to maintain this in a totally new way for us. And in the budgetary and the political world, we're all on different cycles, as I said. There's only one time in the year that you can change the build sequence of space station. It's about June 12th, because it's the only time that fits in between everybody's budget cycles that it won't be a political nightmare for them at home. And even in that, you're always exposed to being linked to some other politics that you have no control over whatsoever. And we have lived through many of those. Why have we been successful? How does this work? First off, NASA had to recognize and really step up to this integrating the managing partner role, firm control of interfaces to all the engineers in the crowd to really understand you just can't possibly have this work where one piece is built in Moscow and one piece is built in Alabama, and they actually work not only the first time, but when that first time is 200 miles above you. The configuration control has been a must, and we have literally had to stretch the bounds of our testing and verification backgrounds that we have all been raised in. But the main thing, and the reason that I really started with the movie, is the relationship building. That's why this program works, is that we have spent a lot of time understanding each other, and we are in a program that all of the partners agree one of the highest values of is the fact that we are working together in the program. As Alain Dubos said in the movie from CSA, 60 years ago, all of these countries were fighting on one side or the other. Now they're all working together, they're all living together. The last piece then is the same chart that you've seen before, but now I was sneaky and changed the color codes on. Everything in red now is already in space. Everything in green are the U.S. elements still to be delivered, and except for one of those, they're all living in Florida, being tested and ready for launch. The Russian elements in yellow, there's still some, not confusion per se, but there's still some debate about which Russian elements will be built because of their fiscal problems. The other partner elements that I talked about, the Japanese elements, the Columbus elements, those are all manufactured. The Japanese elements are all in test at their space center outside of Tokyo, and they'll be shipped to the United States within the next year. The European laboratory has actually been moved from its prime manufacturing site in Torino up to the secondary and outfitting site in Bremen, so it is well on its way. So the space station has come a long way from miles and miles and miles, and maybe even kilometers of paper, to a lot of hardware, a lot of experience with people living and working in space. And it has been an exciting endeavor for me. It has been exciting because it is global, because it is so challenging and so hard, and thankfully because it has worked so extraordinarily well because of the efforts of all the folks that you had an opportunity to see before. So with that, I think I have to be done because I'm not going to take any more dinner time. And the rest of the Triple E still wants your attention for a while longer. So I thank you all very much, and thank you for your interest.
Yeah, we sort of ran out of time. I think the IEEE could learn a lot if we had some time to really pick your brain. We could create our own global community, which is what we're trying to do. Thank you, Mike Haas, for a most illuminating look at a truly global enterprise and engineering marvel. I myself grew up fascinated with science fiction, and I often read about vehicles like an international space station and the engineering and science it would take to make that possible. I find it amazing that what science fiction writers envisioned when I was a teenager, and I won't say how long ago that was, has truly come to pass. So, please accept our thanks and this small token of our appreciation for being our Sections Congress 2002 opening keynoter, Mike Haas. On with the show. Mark Apter